This video is going to be a general overview for the Krebs cycle. Now there might be a couple of different names that you hear. You might also hear tricarboxylic acid cycle, TCA cycle, or the citric acid cycle, but just know that these are all referring to the same thing. Now there are 8 steps in this cycle, and in the first step we have acetyl-CoA, which is a 2-carbon compound, joining with oxaloacetate, a 4-carbon compound, to form what is known as citrate, a 6-carbon compound. So we have the 2-carbon and the 4-carbon backbone joining to form the 6-carbon. And then this reaction is catalyzed by an enzyme known as citrate synthase. Now, moving on to step 2, we have citrate being converted into isocitrate. And this is also a 6-carbon compound. And this is catalyzed by an enzyme known as aconitase. Moving on to step 3. So in step 3, we have isocitrate being converted into alpha ketoglutarate. And this reaction is catalyzed by the enzyme isocitrate dehydrogenase. Now, a few things happen in this step that we need to make note of. The first thing is that we have a release of a CO2 molecule. So this becomes a 5-carbon compound from the 6-carbon, and we also have the release of a CO2 molecule, which is going to end up being our waste product. We also have an oxidation step. So oxidation, remember, is loss of electrons. So isocitrate is going to be oxidized, and then this NAD molecule is going to come and pick up that electron. Remember, these are our electron carriers, to form NADH. So NAD is reduced because reduced is gaining of electrons. So the NAD gained an electron from the isocitrate. Isocitrate is being oxidized. And then we have the formation of an NADH molecule that we can use later down the line. So now moving on to step 5. We have alpha ketoglutarate becoming succinyl. Sorry, that should be succinyl CoA. This is a 4-carbon compound, and this is catalyzed by the enzyme alpha ketoglutarate dehydrogenase. Sorry for the spelling there. There we go. And once again, we see this going from a 5-carbon to a 4-carbon. So we know we're going to lose a carbon. So we have the release of another CO2, which will end up being our waste product. And then we also have an oxidation step once again. So we're going to form another NADH. Remember, alpha ketoglutarate is oxidized because it's losing electrons, being picked up by the NAD, which is going to form NADH, and NAD is being reduced because it's gaining the electrons. And then we also have here, we're adding CoA, so we form succinyl CoA. In the next step, we're going from succinyl CoA to succinate, which is a 4-carbon compound. So we do not lose we do not release any CO2 in this step, and this is catalyzed by succinyl CoA synthetase. Be careful not to mix that up with synthase. And what's special about this step is we actually produce a GTP molecule. So a GTP molecule is produced. After this, we have succinate going to form fumarate, which is a 4-carbon compound. So we didn't lose any carbons there. And this is catalyzed by succinate dehydrogenase. And we're actually going to see the production of an FADH2 molecule, another electron carrier. And we can remember this because once we produce fumarate, just remember the F, we also produce an FADH2 molecule. And then in our 7th step, we're going to go from fumarate to malate. And this is catalyzed by an enzyme known as, enzyme known as fumarase. So fumarate to malate is catalyzed by fumarase. Malate is a 4-carbon compound. And that is our 7th step. Now in our last and final step, we're going to see malate going back to oxaloacetate, catalyzed by malate dehydrogenase. Sorry for the spelling there. So we have the 4 carbons back to 4 carbons, so we don't lose any more CO2, but in this step, we are going to have an oxidation. So we have an NADH that is produced. And so if we take a look back at why it's called a cycle, there's only one input, which is acetyl-CoA. Everything else is used up in the reaction that comes after that, and then we just go back to oxaloacetate, where it can once again join with another acetyl-CoA. So acetyl-CoA is the only input factor. But now let's look at the products. What do we get from this? Because we do have some outputs from this cycle. So let's go back to over here. We see, let's first start off with our electron carriers. So we have an NADH that is produced this step. We have another NADH in this step. And in our last step, we had an NADH. So looking at our NADH, our output, or our products, it's going to be 3 NADH molecules. What else do we have? We have this FADH2, another electron carrier. There's only one, so 1 FADH2. And what else do we have? We have our waste products, carbon dioxide, one right here, another one here. So we have 2 carbon dioxide molecules, and lastly, we have our GTP molecule. So for each turn of this cycle involves 1 acetyl-CoA, so these products are going to be produced for each acetyl-CoA molecule that is inputted into the cycle. So for every 1 acetyl-CoA, we're going to see these products. And that's it. Thanks for watching.